So here we go, part two. I've got a little caffeine in me now, so watch out. Part two, we are going to discuss software, which means applications, which does mean the most important application on any computer, operating systems, and we'll be taking a deeper dive into operating systems. So let's just jump right in to the material. So here we go, software applications. As you can imagine, right? So software in modern networks, it's the heartbeat of modern networks. Why do we need networks if we're not utilizing software that transfers data over a network, right? So, we'll look at a lot of different software packages as part of this lecture. However, the key becomes the operating system. The challenge here is, again, the more applications, the more utilities, whatever it is being used on our network, the greater the attack vector, the more work we have to do to ensure that those are locked down, that they're protected, that they are being secured on a regular daily basis. And we're also going to look at, not in this section, but in a subsequent section, we're going to look at the absolute catastrophe of what happens if you put a bad patch on your network, i.e. CrowdStrike. So anyway, we'll look at that as well. Pretty important to understand that and to learn from that CrowdStrike incident. So we'll dive into that as well. So, again, for digital defenders, it's about the attack vector. It's about securing these apps. It's making sure that end users cannot download apps that we haven't approved, that we haven't protected, okay? And of course, distinctions between general software, specific applications, operating systems, all important to understand because, of course, within an operating system, the attack vector may be higher depending on the user privileges, right? So, software, again, remember terms in gray. In orange, pretty important, write those down. So software comprises any collection of instructions, data, or programs a computer can execute to process and perform specific tasks, whatever those tasks might be, right? Without an operating system, what do we have? We have a boat anchor. We have a very expensive boat anchor. So it transforms, inert circuits and chips into versatile machines capable of a ton of functions, everything from watching Netflix to advanced calculations and now, into AI, right? So again, prime target for cyber attacks. We have to be vigilant in managing and securing every piece of software that is on our network. So moving forward, an application is software. So those terms are kind of used interchangeably, okay? But, program designed to fulfill specific user needs. So, an operating system is in itself an application, okay? Adobe is an application. Adobe happens to be a suite, a productivity suite of applications for what? For photo and video editing, a lot, right? Etc. So, dynamic tools bring computers to life for end users, give us productivity, give us access to the web via a web browser, allow us to play games, media, whatever the case may be. Again, based on the hardware and the application running on it. Okay. So just a quick side trip here. I can't tell you how many people I have helped buy the right computer. They go into Best Buy, they end up buying 40%, 50% more computer than they're ever going to use. And thus they don't want to replace it on a regular basis because every 4 years it becomes very expensive to do so, right? So very important for us to understand how applications are, a path into our network. And we see this all the time, within mobile apps, especially where a mobile app is put on an app store and, 3 months later, somebody determines that there's malware embedded into the app, right? i.e. a means into our secure network, into our digital fortress, if you will. So each application presents that potential vulnerability that we have to manage. So, you can see already that even in a small organization, one IT professional, one cybersecurity professional, one app developer is not going to be enough. Okay, that one person who does it all, there's just too much for one person to learn, as we'll find out. You know, there's careers just in managing and securing and checking the vulnerability of apps. There's secures within being a network administrator where all you're responsible for is keeping the network up. Forget the security. That's a network security administrator's job. Okay. So productivity suites, this is the most common software we see. This is the word processing, the graphics, the spreadsheets, all of those good things. And examples of that, Apple's iWork, Google's Workspace, Microsoft Office are great examples of productivity suites where we're given multiple applications to do the most common things that we do on computers today. Okay. So again, represent potential vulnerabilities that must be managed. Just because it's a suite doesn't mean it's secured as a suite. So I'm constantly updating my Microsoft Office, and one day Word might update, the next Excel might update, the whole core foundation of that productivity suite might update. And we've got to keep all these things up to date. And luckily, there are some tools to help us automate this process. But as we saw in CrowdStrike, if we just let these in and something fails, we become ultimately responsible for it, okay? Even if it's a bad patch from a company, and we'll talk about that. So, operating system, it is the fundamental software that manages the computer hardware. It's what creates the interaction between the hardware, all of the hardware. So again, if we have, say, a custom video card in our computer, we need to have that software, that driver that interacts with the operating system so that it can manage that resource as a complete computing unit. Okay, and that goes with everything that we put in there. So it manages the critical operations, memory management, file systems, process scheduling, etc. And again, establishing a baseline for security policies and controls is huge here. That means, how much are we going to lock down? What is it that our end users, right, in an endpoint computer, what is it our end users need on a laptop that maybe is different from a desktop? So we create that baseline, securing the computer as much as we can, and then again, opening it up for resources versus closing down resources we're not using. Okay, so operating systems are the backbone of any computing device. They provide the environment for applications to run. So without an OS, we don't have applications. Now keep in mind that a lot of the modern OSs come with some default applications. Windows comes with a mail application that is not Outlook. Okay, it comes with a photo editing software that, is not Photoshop. Okay. But be clear, those are applications. They are not the operating system itself. So be aware of that, okay? These are tailored to devices, different use cases, as we'll see, different clients, servers, mobile devices, embedded systems, all have unique operating systems that are designed to be, large for a lot of functionality, say in an end user's Mac, versus very little functionality, say in the head unit of your automobile, right? That's now the radio and now operates the maps and all that good stuff. In addition to all this, we bring in this idea of virtualization. And virtualization in itself can be a career, again, in itself. It's the idea of putting multiple operating systems onto a single piece of hardware, a server. My laptop, I've got a Dell. It's, a higher end Dell XPS laptop. It has 64 gigabytes of RAM. It has 12 processors. I utilize a software application called VirtualBox that allows me to virtualize additional server operating systems in Linux, in Unix, in Windows, as well as endpoint client operating systems like Windows 10, Windows 11, all the way back to say off Windows 97, for example. Okay, so sorry, XP, my bad. Windows 7, sorry. So client operating systems designed to provide that user-friendly interface. So, way back when I first started using a computer, there wasn't this graphical user interface that's available today. It was command line interface. And we still see a lot of that on Linux because the graphical user interface tends to use a ton of resources in processing the graphical user interface that allows you to easily click versus, memorizing and knowing a command to, say, navigate the operating system structure. Okay. So Windows, you're probably pretty familiar with. It is personal computers developed by Microsoft. It is proprietary. We've got Mac, we've got iOS. We'll go into all of those. Proprietary from Apple, right, for desktop and laptops. And then finally, Linux, again, is that open source. So that source code is available for us to modify and customize. And standard applications in there, well, Kali Linux, okay, which is, the de facto penetration testing, cybersecurity, securing and auditing application. Okay, and as we'll see, those can run on desktops, those can run on ARM devices such as single board Raspberry Pis. In addition, we're seeing a lot of popularity here because the cost is free, and then there are companies that are leveraging Linux, leveraging Unix, Linux variants, etc., to create production operating systems such as Red Hat, where we can actually utilize open source, but we get the support from a company that helps to better secure, because again, it doesn't become our responsibility to manage the whole thing. Okay. Server operating systems. So, Windows Server, Server 22, Unix. We see a lot of Linux used in data centers today. Okay. Because again, minus the graphical user interface, all the resources are put towards processing. Okay, CentOS, Ubuntu Server, all great examples. Mobile operating systems, I imagine you're looking at a phone. I always shut my phone off, do not disturb, so it doesn't go off when I'm making these videos. iOS for Apple, Android for, everything else. Android is a Linux variant. It's based on a Linux kernel. It's designed by Google. Many different hardware manufacturers utilize Android, whereas if you want iOS, you're going to get an iPhone, right? That's proprietary. So you can see that distribution of market, if you will. These today, huge vulnerabilities for the cybersecurity professional. If these are phones owned by the company, you are responsible for protecting them, encrypting the data on them, as we talked about with AES previously, protecting them and being able to, say, remotely wipe them should a user lose it. We want to be able to know that as long as it's connected to the internet, we can go ahead and remotely wipe it. So that does bring us to embedded systems. So here's an example of, a silly example, but the new 2024 Toyota Tacoma, it has this big screen, more computers being integrated into our driving experience, into managing the engine, right? Managing the transmission, managing the operation of the vehicle for safety and fuel efficiency. So all of those sensors now, front end collision, side detection, cameras, all run by an embedded operating system, okay? So examples of that. Embedded Linux is a scaled down version. Now, not only do we see this on head units in cars, but we see this a ton in IoT devices. And again, this software and these devices are being put out so quickly that there are inherent vulnerabilities in the code that hackers are taking advantage of. Another sort of unknown, maybe now it'll be more known to you, VxWorks is a real-time operating system, okay, used in embedded systems requiring high reliability and performance. So we see these a lot in government applications. So that brings us to my absolute favorite. If you're a student of mine, you're like, oh my God, please don't spend a lot of time on this slide. I won't, I promise. But I love Raspberry Pi. It is such a great way to learn Linux. If you don't have one, I do suggest you get one today. The Raspberry Pi 5 does have the ability to be slaved to an SSD, which means the speed is astronomical on these things. Great processors, wonderful memory at 8 gigs. And from a hacking standpoint, Kali Linux runs wonderfully on these. It's a great, inexpensive way. You know, you might be looking at a couple $100 for this whole unit here. Okay, so single board operating systems are just that. They're operating systems designed for computers that are built on what's called a single board circuit. So this is the single board. We've got everything we need: USB 3, USB 2. We've got Ethernet. We've got Wi-Fi. We've got multi-core. We've got HDMI. These things will power 2 4K monitors without any problem at all. Okay, operating systems in this category: Raspberry Pi OS. Is a great place to start, Ubuntu Mate, and then again, Kali Linux. So, you know, in this coursework, students will be using Kali Linux on Raspberry Pi. They'll remote into Raspberry Pis. They'll learn some basics of Linux, which is very important to understand as a cybersecurity professional, and, you know, as well as getting to know Kali. So, great place to start. So, as it pertains to cybersecurity professionals looking at a deeper dive, you know, security measures, tailoring security measures according to specific characteristics of the operating system, of the software. Again, we've already talked about virtualization, you know, from a standpoint of here's the hardware. We add this layer called the hypervisor, and then we can add as many machines as our hardware will support. So this could be a Windows 10, this could be a Windows 11, this could be a Kali Linux, and suddenly on one system, and by the way, we can create separate networking, so we can keep this segmented securely from our base operating system or from web access if we need to, you know, so that we have a secure lab environment in which to play in. Okay, I commonly use that. You know, I'll go out, find a vulnerability such as a ransomware, you know, download that, see what happens, right? I haven't done that in a long time, but malware, for example, what's going on? Currently, I just read an article in regards to some new ransomware coming about for end user computers, which means your computer at home. So I'll go through the rest of this pretty quickly. We're kind of over time for this video. When we talk about more software, these should be things you're used to seeing or using: web browsers, Chrome, Firefox, Edge, communication such as Slack. My students use Microsoft Teams, Zoom, WhatsApp, security software, Norton antivirus, you know, McAfee. Even though I'm a cybersecurity person, I still utilize a third-party internet security application just to make sure I don't accidentally click on that link. Okay, you know, that affects my computer. Development software, Visual Studio I use a lot. It's a great tool, Eclipse, etc. So different softwares for different purposes. Database softwares for back end of, you know, databases, MySQL, Oracle, Microsoft's proprietary SQL Server. Enterprise you may not be familiar with. That's SAP, Salesforce, Oracle. These are what's called enterprise resource planning software. This is software from the front end to the back end. It says, you know, ultimately a single combined suite that does everything a business needs to do, from managing customers to manufacturing products to, you know, vendor supply chain to customer service, to shipping, the whole 9 yards. Entertainment you're probably pretty familiar with. And then next chapter, we're going to talk in detail about cloud services: Amazon Web, Google Cloud, Microsoft Azure. Those are sort of the big three. We also have utility software such as CCleaner, you know, WinRAR, zipping software, you know, 7-Zip, for example, you know, other utility software that we use on computing. Now, again, you know, understanding and proactively managing software is a huge essential part. Again, it is a huge attack vector that we have to deal with. So each piece of software must be known. We need to know what its vulnerabilities are. We need to know that it's being patched on a regular basis, and that we are testing those patches. Very important. So in part 3, let me get there, we will begin our conversation in regards to endpoint security. So see you then.